While the James Webb Space Telescope detects one structure after another in space that shouldn't actually exist in this form, there's one thing we shouldn't forget. Our Earth also has the seemingly impossible in store. For example, researchers have recently identified anomalies in the Earth's mantle that look like submerged tectonic plates. The problem, however, is that this simply cannot be the case. After all, the strange formations are located far away from any plate boundaries. So how is this possible? What explanation do the experts have for this confusing discovery? And could there really be an impossible sunken world hidden deep below the Pacific Ocean? Our blue home planet never takes a break when it comes to plate tectonics. Driven by convection currents in the Earth's outer mantle, our planet's tectonic plates are constantly drifting away from each other, moving towards each other, colliding, or rubbing against each other. But how do we actually get to the bottom of the background of these spectacles that are constantly unfolding beneath our feet? Well, in this regard, geologists have a colleague who answers to the name of earthquake. More precisely, this refers to the seismic waves that can be analyzed with the help of seismographs, thus providing insights into the inner structure of the planet. But if you like, the proverbial ultrasound of the Earth was limited for a long time because, in fact, experts relied on only one type of earthquake wave for this purpose for a long time. However, thanks to the research team led by Thomas Schoen from the Swiss Federal Institute of Technology in Zurich, this situation is now finally a thing of the past. In contrast to previous methods, the scientists used what is known as full waveform inversion for the first time, which in plain language means that all types of seismic waves were taken into account. The gigantic data sets that resulted from this were then evaluated with the help of a supercomputer, and the model that was created on the basis of this revealed something that immediately caused huge confusion among researchers. As briefly mentioned at the beginning, the experts saw areas in the Earth's interior that looked like the remnants of sunken tectonic plates. Among the largest of these special finds is a region that lies between 900 and 1,200 kilometers below the Western Pacific Ocean. A series of smaller, vertically aligned areas was also identified at a comparable depth west of South America. The small but crucial problem here, however, is the fact that the ominous submerged plates are located in places where, according to our current assumptions, they should not actually exist. Specifically, their position under large seas and in the interior of continents is much too far from the plate boundaries we know of, making it difficult to explain how the tectonic plates could have submerged there in the recent geological past. So what about these mysterious sunken worlds in this context? Or is it possible that these are ultimately completely different structures? The search for explanations? Well, in both cases, the answer is we have no idea. In this regard, Thomas Schoen's team openly admits that their new model has uncovered such anomalies throughout the Earth's mantle. But in the same breath, they don't know what kind of structures we're dealing with here. In reference to their new measurement method, the experts use the example of a doctor who has been examining his patient's blood circulation for decades with an ultrasound device. But as soon as the doctor is given a newer, significantly better instrument, he suddenly discovers an artery that doesn't belong in that part of the body at all. Or, in the case of patient Earth, a series of confusing structures in the planet's mantle that have left experts scratching their heads. Consequently, scientists can only speculate about their discovery at present. One approach is based on the assumption that the anomalies are not so-called subduction zones. To explain this briefly, these are the areas where oceanic and continental plates meet and where one tectonic plate slides over or under another plate. Instead, we could be dealing with much older relics here, for example, with very old silicate-rich material that has been there since the formation of the Earth's mantle around 4 billion years ago and has been preserved to this day despite all convection movements. Alternatively, however, it could also be regions in which iron-rich rock accumulates over billions of years as a result of mantle movements. This is the case, for example, when the oceanic crust separates from the oceanic lithosphere, especially in the mantle transition zone. The fact that the basalt-enriched mantle rock appears as plates in the researchers' data could, in turn, be due to the higher seismic wave velocities that it typically possesses. And this is precisely where the mystery lies. The waves that the experts use for their model basically only reflect the speed at which they travel through the Earth's interior. However, in the overall context, this does not do justice to the complex interior of our planet. That's why, according to the experts, it is essential to get to the bottom of these anomalies in the future with even better models. These must then also take into account the different material parameters that result in the different wave velocities of the various wave types. This mysterious find raises further questions about the Earth's mantle. When you hear the keyword Easter Island, what comes to mind? The equally gigantic and mysterious Moai statues? The cryptic Rongorongo script? Or the lava rock discovered there, which is over 150 million years older than the tectonic plate on which the island sits, thus raising new questions about the behavior of the Earth's mantle? If it's the latter, you will certainly already know that a research team led by Yamura Roazagrani from the University of Kiel went to Easter Island a few months ago to test an established theory that is, however, surprisingly difficult to prove. The prevailing theory is that our continents literally float on the viscous rock of the Earth's mantle, and that this constantly keeps the tectonic plates of the Earth's crust in motion, like a kind of conveyor belt. To better understand the engine of continental drift, scientists have carried out new measurements on Easter Island, and with good reason. Located about 3,800 kilometers from the South American mainland, the island consists of several extinct volcanoes. The first lava deposits there date back 2.5 million years to an oceanic plate located directly under present-day Easter Island, hardly older than the volcanoes themselves. And so, it came about that the researchers collected several lava rock samples to determine the exact age of the island. More specifically, the experts focused their attention on the zircon it contains, a mineral that crystallizes as soon as magma cools down. Given that the uranium contained in the zircon eventually decays into lead, and that the rate of this decay is known, the lava samples can therefore reveal how old they are. And yet, at the end of the investigation, a surprising result was cautiously formulated. The zircon was by no means only 2.5 million years old. Instead, it was up to 165 million years old. So, the material must have existed when dinosaurs still roamed the Earth. But how is that possible if the plate on which Easter Island sits is so much younger? Is the Earth's mantle very different from what we thought? Well, in this regard, the researchers see only one possible explanation, namely, that the minerals examined cannot come directly from one of the Easter Island volcanoes. Instead, their roots must go back to the actual source of Easter Island volcanism, which is located deep in the Earth's mantle. In fact, the corresponding structures are hotspot volcanoes, fire mountains created when magma rises through weak spots in the Earth's mantle. The columns of magma that melt their way up hundreds of kilometers are also known as mantle plumes. And although this approach may seem plausible at first glance, on closer inspection, it raises more questions than it answers. Although mantle plumes are fundamentally anything but short-lived, 165 million years of continuous activity seems unusual even for them. And to get to the bottom of this mystery, the researchers had no choice but to go back in time. In other words, they reconstructed the tectonic plates that must have been above the plume at that time. The bottom line was the realization that 165 million years ago, there was a volcanic plateau at the site of Easter Island, which drifted away 55 million years later and disappeared under the Antarctic Peninsula. Coincidentally, this happened exactly during the period when the phase of crustal deformation and mountain building began, which is still poorly understood today. But what is even more important is the fact that the Easter Island mantle plume could actually have been active for 165 million years. And now, our channel Digital Discoveries gives you a reason to click the subscribe button. Click subscribe and the thumbs up to never miss a new video from us again. We'll see you soon.